Hi, welcome to another class with Physics Anchor. Today we'll be having some questions from JAMB past questions for the benefit of those people that will be writing JAMB. Okay, let's get to work. Now the questions we have on the board, there are three in number, and these questions is from the topic motion in physics. So we start with question number one. An Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? So, analyzing this question, we have an Air Force jet flying past an anti-aircraft gun. So they want us to calculate the distance that the Air Force jet has gone 5 seconds after the anti-aircraft gun was fired. So analyzing this question, we can see that going by our culture of writing out the given parameters so that we can know what we need to find, we have the speed here. The speed, which we can call V, equals 335 meter per seconds, and then we are being given the time t equals to 5 seconds. That is for 5 seconds. So what distance has it covered, or what distance has it gone? So when you hear the question like how far simply means distance. So they are not asking you for the time, they are asking you for the distance that the Air Force jet has covered after 5 seconds that the anti-aircraft gun was fired. So this is everything that they have given to us. There is nothing like initial speed or final speed. There's nothing like acceleration. The only information you have are these three. So by going by these parameters, we know that what we need to actually use as a formula is the speed equals to distance over time. So, and then we can say our distance will be v times t, which according to this is 335 times 5. Okay, so let's multiply that. That will be 5. That 2. That will be 17. Okay, and remainder 1. That will be 16. That will be 1,675 meters. So let's check what we have as the options. So option A is not option A, it's not option B, it's not C. D, 1675 meters. So this is the correct answer. So by stating out your parameters, it will help you to actually know the correct formula to use. So you know that your speed or your average speed equals to total distance covered over total time taken. So here, just the distance they want you to calculate, you have the speed, and then you have the time, so you can easily get your distance. So that is that about question number 1. So let's move to question number 2 without wasting our precious time. Okay, question number 2. A train has an initial velocity of 44 meters per second. So initial, so that helps us to know that this is u. Okay, and an acceleration of -4. So acceleration equals to -4 meter per second square. Its velocity after 10 seconds is dash. So that means that our t is equals to 10 seconds, and they want us to calculate the final speed. So don't be confused with having your acceleration as a negative value here. Of course, you know that means that the acceleration they are talking about here is actually on the negative side, which means it is deceleration or retardation. Simply means that when you have your acceleration means that there's an increase in speed from a lower speed to a higher speed. But deceleration or Retardation simply means that what? There is a reduction in the what? In the acceleration. So it's in the speed rather. So there is a reduction in the speed. That's from higher speed to a lower speed. So in this case, when you look at it, if you have negative what? Acceleration, it means deceleration or retardation. It means that what? The speed actually reduce. So the speed actually reduce, and you are going to see it. The value of this final velocity must be less than this what? Initial speed, because what we have here is not really acceleration but retardation, or what we can call deceleration. So when you have increase in speed, that is what? Acceleration. And when you have what? Decrease in speed, that is what? Deceleration. So you need to understand that background in case you have any question relating to that. So we can see that we have UATV. So the formula we'll use is V equals U plus AT. So let's put all the parameters. V unknown, U is 44 plus our acceleration, which is minus 4, and our time, which is what? 10. So you can say V equals to 44 plus times minus will give us minus, 4 times 10 will give us 40, and our V will be equals to 4 meter per seconds. Okay, so let's check the option. So you can see even the V that we got now, you can see the difference. The initial speed is 44, but the final speed is 4, which means that what? The speed actually reduced, and that means what? Negative acceleration, which otherwise means deceleration or retardation. So if you check the option, it's not A is 2, it's not B, is B, because our B is 4 meter per second. So that is B. So it's not 2, it's not this, it's not this. So the correct option is what? B, where we have 4 meter per second. I hope you understand that. So it's as straightforward as that. So let's go to number 3. We are moving to number 3, question number 3. If a car starts from rest and moves with a uniform acceleration of 10 meter per second square. So we can see that what? It starts from rest. Okay, that means that the initial speed will be 0, and with a uniform acceleration of 10 meter per second square, A equals to 10 meter per second squared. Okay, for 10 seconds, total time. Okay, you will know why I'm writing time like this later. By the time we begin to analyze it, it's 10 seconds. The distance it covers in the last 1 second of the motion is, so they want us to find the distance for the last 1 second of the journey, and that's the question mark. Now, when you look at this question very well, JAMB actually loves questions like this. In fact, there are so many past questions you will check that takes this form. So it's very important that you understand how to analyze questions like this. Now, let's try to explain this using something that looks like a number line. Okay, the journey starts from rest. So I have 1, 2, these are seconds. I'm actually using this line to represent time. Okay, this line represents time so that you understand it. 4, 5, 6, 7, 8, 9, and 10. So what this simply means is that the journey took place for 10 seconds. Now, they want us to calculate the distance here, the distance covered in the last 1 second, that is, and that last 1 second will take place between the 9th second and the 10th second. That will be the last 1 second. It will be the journey between the 9th seconds to what? To the 10th second. So they want us to calculate the distance covered, from these 9 seconds to what? 10 seconds. And the only way we can do that is simply that we need to first find the distance covered for 9 seconds. That's, let's call that S9. Okay, and the distance covered for the entire journey, which is what? 10 seconds. Let's call that one S10. So if you look at this very well, you can see if we calculate the total distance covered for 10 seconds, and we calculate what? The distance covered for 9 seconds. So subtraction of this from this will give us what? The distance, okay, that we need for the last 1 second. I hope you understand the analysis. That's how you can actually what? Go about analyzing this question. So it simply means that what? S last 1 seconds now will be equals to S10 minus S9. Okay, so in fact, in subsequent video, I will still solve 2 or 3 more questions of this form for you to actually see that it's just the same analysis. Once you understand the analysis, you will always get your what? Your correct answer. So now that I've done the analysis, I hope you understand. So let me clean this and then we solve. Let me clean the analysis up and then we solve. So the first thing we need to do is for us to find our what? S9, okay, which is the question mark now. So in that case, time will now be what? 9 seconds, because it's what? Distance covered for 9 seconds we are looking for. Other parameters have been stated here. So I have U, I have A, okay, I have what? T, okay, there is no V, okay, so, and I'm looking for distance. So I know that the formula that is befitting is what? UT plus half AT squared, okay. So that will be S9 equals, our U is what? 0, and our T in this case is what? 9 plus half, our A is 10, they have given us, and our T is 9. So that will be S9 equals to 0 plus half times 10 will give us 5 bracket 81, and that will be S9 equals to 5 times 1, 5 times this, that will be 4 zeros. So that will be the distance covered in the first 9 seconds will be 405 meters. So the next thing is for us to calculate what? Our S, okay, 10, which we are going to apply the same formula, okay. So we are calculating our S10. Our U, in this case, we want to calculate S10. So our T will now be what? 10 seconds, because the time now is 10. So we'll say our S9 equals, our S10 rather, now equals U, which is still what? 0, okay, bracket T, which is now what? 10, plus half, I'm still using this formula. This formula is what I'm following. U0, T 10 plus half A is still what? 10, and what? Our time T squared is 10 this time. So it's 10 squared. So I can say that what? S10, this one will be what? 0. So I'm focusing on this. Half times 10 will give us what? 5. 10 squared will give us what? 100. So S10 is going to be what? 500 meter. So now the question they ask us, X last 1 second, S last 1, okay, seconds that they want us to calculate equals S10 minus S9 by the analysis I did, and that would be 500 minus 405, which will give us 95 meter. Okay, that will be 95 meters. So let's go to our option. So by the time you check in our option here, A 95 meter, of course, since we have seen our correct option in A, we know that what? A is the correct what? Option, which is what? 95 meter. We have a lot of questions like this that take this form, and even in subsequent video, I'm going to solve something that look like this so that you would perfect questions of this form. So I hope you have gained some additional knowledge in today's solution that we have done to some questions under motion in physics. Please try to share these videos with other students around you. Hit the notification button, subscribe, share, comment. Let me know how well you are coping with all these videos I've been dropping for you, how helpful they have been in preparing for your examination. I wish you all the very best in your examinations. God bless you. Bye for now.